Now that we've reviewed our arithmetic sequences, we're going to move forward and talk about arithmetic series. What a series is we're going to take a part of the sequence and we're going to add it together. That's it. So I have part of an arithmetic sequence here, starting at 5, ending at the 105. If it was a sequence, it would continue forever, but because it's a series, we're just going to add this portion together. Okay? There's a trick to adding these together. Instead of having to find all of these missing terms, we have a couple formulas that we can use to add our values together. So again, we just want to understand what our variables mean, and then we can just find those answers, plug them in. So here, our n is going to tell us how many terms that we're adding together. And right now, that's something we don't know. I'm going from 5 to 105, but I don't know how many terms are here in the middle. So we would have to figure that out. Then I have my a sub 1, which is the first term of the series. Not necessarily the first term of the sequence, but the first term of the series. And then a sub n is the last term in the series. Not the last term of the sequence, but the last term of the series, the piece that we're going to add together. Over here, we would still need to know n, a sub 1, and we would have to know d, which is our common difference. So both of these formulas can be used pretty much at any time. It's just what information do you know? Plug it in and find the sum. All right? So this first one here, I know my first term, so I'm going to say a sub 1 is 5. I know my last term, a sub n is 105. And I also know my common difference. That's how we're going from step to step. And here I can see I'm just adding 5. But if I wanted to use this formula, I still would need to know n. So for both of these formulas, I need to figure out what does n equal. To do that, we're going to go back to our explicit formula. That way, I can figure out what n equals. So in this case, I know, let's say I know my third term. No, I want to use 105, sorry. I want to know 105. What term is this? Because that's going to tell me how many terms are in this list. So using our explicit formula, here's my first term, my common difference. Now I can solve for n. So I'm going to minus 5, so I get 100 equals 5 times n minus 1. Divide by 5, so that's 20. So I have 21 terms. I went off the board there. So that was supposed to be an arrow. Don't judge me. I add that one over, and I'm getting n is 21. Okay, so now I have every variable needed. I could use either one of these formulas to find the sum. So I'm going to go ahead and just come here. My sum, I have 21 terms. Put that over 2. My first term plus my last term. So what I'm going to do here is I'm going to take the 5 plus 105. I'm going to divide that by 2 and then times it by 21. And that sum is 1,155, excuse me. Okay? So all we're doing is taking all of these values in our sequence, but we're going to just find this portion of the sequence, which makes it a series, and we add those together. Just to show that this formula would also work, we're going to have the sum, I'm going to have 21 over 2, 2 times 5 plus 5 times 21 minus 1. So order of operations here, I'm going to take 21 minus 1, which is 20, times 5, which is 100, plus 10, that's 110. And that's right where we were here. 110 divided by 2 times 21. Okay, so we have a second series here. we are actually subtracting from term to term. Okay? So all that's going to change here is our D is going to be negative. We could use either formula, but I'm going to say I have my first term, which is 218. I have my final term, which is negative 146, and I just want to know n. So I'm going to use this first formula here. So I'm going to go back to my explicit formula, and I'm going to say negative 146. Sorry, that's supposed to be a negative 218. That would be crazy if it wasn't. Equals negative 218. And our common difference here, it looks like actually I'm still adding 3, but my numbers just happen to be negative. To go from term to term, it looks like we're just adding 3. So I'm going to add my 218 over. And just for time's sake, I'm going to jump here to my calculator. So I get 72 equals 3, n minus 1. So n minus 1 equals 24, so n is 25. So to find the sum of this series, since n is 25, all I'm going to do is plug that into this equation here. So my sum is going to be 25 over 2, my first term, plus my last term, plus the negative, or you could just subtract it. It's going to get you that same answer. That's 218, not 208. So negative 218 minus 146, divide that by 2, times it by 25, and that total is negative 4,550. Getting a little sloppy there, but I was trying to hustle. Okay, so you do need to know these formulas. You need to know what the variables mean and how to find each variable. Plug it in, and there's your sum.